platform to upgrade the knowledge and skills and encourage trained human resource from dairy and food industries and promote bioentrepreneurship in fermented food sectors. Thank you so much. Over to you, Dr. Mittal.
Thank you, Dr. Sujit. I now invite Dr. Srija, Head of Dairy Microbiology Department, SMC College of Dairy Science, Kamdhen University, for the introductory presentation on SMC College of Dairy Science.
Thank you, Dr. Mittal. Is the PPT visible to you?
No.
No, ma'am.
Not yet. Once it is
Madam. Sujit, make you presenter भेजा मैडम को presenter का option.
Can you, ma'am, can you see this one option?
मेरे पास आया है, आप मैडम को भेजो क्योंकि सेम लिंक यूज हो रहा है ना.
Okay, same link. हाँ, ma'am, you are the presenter now. I will make the presenter. Yeah.
मैडम देखिए अभी आया क्या?
Yes, yes. You can see your desktop screen.
अभी ठीक है.
PPT ओपन कीजिए. हाँ, ओपन कीजिए. बस फुल स्क्रीन कीजिए. आ गया.
ओपन कर.
हाँ, फुल स्क्रीन कीजिए बस. आगे मैडम.
ठीक है.
Yes.
Now you can. हाँ, yes.
Is it visible?
Yes, ma'am.
Yes, ma'am.
This is visible. Madam, yes, it is visible and full screen also.
Okay. Respected Dr. Atanu Jana, Principal SMC College of Dairy Science, Dr. J.B. Prajapati sir, ex-principal SMC College of Dairy Science, all the invited speakers, DBT Bairak members, Dr. Shilpi Gupta, Dr. Sujit, and my colleagues, Dr. Subrata Hatti, Dr. Mittal, and all the participants of this webinar. Wish you all a very good morning. And it's my proud privilege to give an overview regarding SMC College of Dairy Science. Sheikh Mansukhlal Chaganlal College of Dairy Science is located at Milk City of India, Anand, Gujarat. And the college has started as a grant-in-aid institution in 1961 with the financial assistance from the government of Gujarat. The college acquired the status of Faculty of Dairy Science in 1972 with the formation of Gujarat Agriculture University. And in 1974, the intake capacity of the BSc Dairy Technology increased to 40, and the PG program started in 1977 in 4 major disciplines: dairy engineering, dairy technology, dairy chemistry, and dairy microbiology. Then in 1990, the nomenclature of the degree changed from BSc Dairy Technology to BTech Dairy Technology as suggested by the ICAR NDDB joint panel. And for the benefit of the BTech Dairy Technology students, a commercial dairy plant, Vidya Dairy, was started for providing 1-year hands-on training to the BTech Dairy students in 1994. In 2004, the college became a part of Anand Agriculture University and started a PG program in food biotechnology and postgraduate diploma in dairy and food quality assurance in 2005. Later on, an AC modern classroom complex was made for the benefit of the UG students, and the admission capacity to BTech Dairy Technology raised from 40 to 67 in 2011. And further, to provide a hands-on training to the BTech Dairy Technology students, a fermented milk plant at Vidya Dairy was started in 2014. Later on, an ice cream plant was started in 2018. And a new sensory lab was established in the college building in 2019, and a new building, Vishwakarma, that is for the engineering laboratories and workshop for the benefit of the students, was started in 2020. The college became a part of the Kamdhenu University in April 2021, and the college introduced the PG program in MBA in Dairy and Food Business Management in 2022 with an intake capacity of 10 seats. The college has 6 departments and 1 Dairy Vigyan Kendra: Department of Dairy Technology, Department of Dairy Processing and Operations, Department of Dairy Engineering, Department of Dairy Microbiology, Department of Dairy Chemistry, and Department of Dairy Business Management. The college has trained and provided manpower to all the states of the country, as well as to some neighboring countries like Nepal and Bhutan. And all the students who have passed out from this particular college are serving at top positions in all the dairy plants in the country, and as well as other industries also, like administrative positions, as well as in the food industry and ingredients industry, etc. The academic program comprises of undergraduate level BTech Dairy Technology course of 8 semesters, and in the PG programs we have MTech as well as PhD in 4 disciplines, namely Dairy Technology, Dairy Engineering, Dairy Microbiology, and Dairy Chemistry. In addition to that, the recently started MBA program for the Dairy Business Management comprises of 2 years. The BTech Dairy Technology students of this college, they spend their initial 3 years at the college, gaining theoretical knowledge as well as practical knowledge. And in the 4th year, they spend at Vidya Dairy, where they are exposed to hands-on experience to develop their business skills. Vidya Dairy is an ISO certified dairy plant with current turnover of rupees 250 crores. The plant handles around 1 lakh liters of milk per day and sells various milk and milk products under Amul brand name. The plant is operated by the final year BTech Dairy Technology students of this college, and the college and the dairy are also involved in providing various training programs for the technical manpower of the dairy plants of India. And I'm proud to say that the college has ensured 100% placement for the undergraduate students till now. In addition to the various big dairy plants in the Gujarat states, some other employers, major employers include National Dairy Development Board, as well as Gujarat Cooperative Milk Marketing Federation Limited and IDMC Limited. With a view to have an overall personality development of the students of this college, the students are being given opportunities for various co-curricular activities, glimpses of which activities are shown here: annual day celebrations, National Day celebrations, Women's Day, Sports Day activities, as well as various NSS activities. The college research has been progressed with the help of various externally funded projects. The faculty has handled externally funded projects, and they are still handling the externally funded projects by Indian Council of Agricultural Research, ICSSR, Gujarat State Biotechnology Mission, Department of Biotechnology, Department of Science and Technology, as well as other private players. The college has a very strong alumni association comprising of members from India as well as abroad. And under the alumni association, various activities are being carried out. The happenings in the college are being communicated to the alumni through a DSEA newslink, which is published twice in a year. The alumni association also conducts alumni convention and national seminar once in 2 years, as well as 2 unique events: National Dairy Products Judging Contest, as well as National Dairy and Food Quiz Contest annually, in addition to various dairy doorstep seminars, as well as guest lectures cum interaction sessions. The college has received the Best Dairy Science College Award prize. And in the context of this 2 days webinar, if I talk about the contributions of SMC College of Dairy Science in the area of probiotics, fermented foods, health, and social well-being, I can very proudly state that the college is a pioneer in probiotic research in India. A Dairy Microbiology Department of SMC College of Dairy Science, the work on probiotics has started as early in the 1980s. The college is also recognized as the headquarters of Swedish South Asian Network on Fermented Foods, a professional body of international status comprising of scientists academia as well as researchers who have a common interest in fermented foods, its health benefits, and the social well-being. In addition to that, the various activities which have been carried out in the area of probiotics and fermented foods ensured that the Center, Dairy Microbiology Department, has been recognized as the niche center of excellence on functional fermented dairy products with the symbiotics by the Indian Council of Agricultural Research. Further, ICR has recognized the Department of Dairy Microbiology as a cooperating center in the National Network Project on veterinary type cultures for preservation of biodiversity of lactic acid bacteria from the traditional fermented foods of western parts of India. The college is also the center of Indian Dairy Association Gujarat chapter. At SMC College of Dairy Science, Dairy Microbiology Department, the research on probiotic strains, their isolation, identification, characterization is going on since early 1980s. And the work has various research activities has resulted into coming out with a number of dairy starter cultures as well as well-characterized probiotic strains possessing specific functional properties. For example, some of these strains are can be used as good starter cultures for dahi, lassi, cheese, and other fermented dairy products. And many of these strains have been found to possess specific health benefits like antioxidative activities, ACE inhibitory activities. Some of them are found to be good EPS producers. And these strains are available for commercialization also. And we are regularly supplying these strains to educational institutions for research purposes as well as to the dairy plants and to the entrepreneurs. These indigenous strains have been used for developing an array of functional fermented dairy products, and a few of these products have been studied for their health benefits also. For example, symbiotic lassi has been studied for its immune stimulation in geriatrics through human clinical trials. Further, the milk millet products developed have been studied for its potential anti-obesity effect and anti-diabetic potential. A barley-enriched probiotic fermented milk has been found to possess anti-urolithiatic activity. And in addition to that, a peptide-enriched dahi symbiotic fermented milk possessing ACE inhibitory activity, pickle-flavored Greek yogurts, symbiotic cottage cheese. All these products have been developed and the technologies has been optimized for such products, though these technologies are available for commercialization. In addition to that, our probiotic strain Lactobacillus helveticus has been studied for its potential cosmetic applications, oral health benefits, as well as for vaginal health applications. Lots of research on bioactive peptides have been carried out since 2012 in this Department of Dairy Microbiology, SMC College of Dairy Science. And bioactive peptides possessing specific health benefits like ACE inhibitory activity, antioxidative activity have been isolated and identified from the milk of indigenous breeds of milk animals, and the peptide sequences have been submitted to BioPep databases for the benefit of the scientific community. And the various activities which are happening in the SMC college, the college made it a habit to reach out to the stakeholders for the benefit of the stakeholders as well as to the society at large. So the technologies which have been developed at the college have been compiled in the form of a booklet, and the industry meet is held to communicate the same to the industry for their benefits as well as to the college and the students. And a number of technologies have been transferred to the industry. And recently, the modified adulteration detection methods for milk developed at the Dairy Chemistry Department of the college has been included in the FSSAI Manual of Methods of Analysis of Foods, Dairy and Dairy Products. Further, the faculty are continuously involved working with the Extension Education Department of the university to communicate the latest developments as well as the research activities in the college to the farmers and to the entrepreneurs for taking advantage of these research activities as well as the technologies developed. And the faculty are also making regular visits to the adopted villages to communicate with them regarding the happenings and in the research activities and also to solve their problems. In addition to that, the faculty of SMC College is also serving as resource persons for the training programs which are being organized for the industry as well as for the entrepreneurs by the Vidya Dairy. These are some glimpses of the hands-on training which is being provided by our Dairy Vigyan Kendra to women farmers on preparation of traditional fermented milk products. In order to make the younger generation aware of the health benefits of the fermented milks and as well as the probiotic fermented dairy foods, we regularly organize awareness programs. One such awareness program is the Probiotic Awareness Day, which is organized in association with the Gut Microbiota and Probiotic Science Foundation, as well as the Swedish South Asian Network on Fermented Foods. So since last 3 years, we are organizing such a program, and with each passing year, we have seen an increased number of participation from the schools in and around Gujarat state. In addition to that, the faculty was also actively involved in sensitizing the society regarding the immunity boosting dairy foods, particularly the fermented dairy foods during the COVID-19 pandemic through various social media platforms. And the college also regularly organizes conference, webinars, etc. And recently we have organized a webinar on the functional fermented foods, its future prospects, and also role of fermented foods in the pandemic era. And regarding some of the present research activities, which has reference to this 2-day webinar, include exploring the cardioprotective effect of the symbiotic fermented milk and in vivo animal study, and the obesity effect of protein-rich fermented milk, and exploring the postbiotics of probiotics and its role in shelf life extension of dairy foods, bioactive whey peptides, production, characterization, and biofunctionalities, use of spices in shelf life extension of fermented dairy foods, and exploring the prebiotics and its application in development of the symbiotic dairy foods. Thank you all, and I take a moment to thank Kamdeni University for letting us organize this 2 days webinar, and also I want to thank DBT Bairak for supporting us. Thank you, and have a great day.
Thank you so much, Srija madam. Now let us move towards the technical part of this 2-day webinar. Today, we have with us 3 highly experienced speakers from academia as well as industry. They are going to speak on different topics like dairy starter culture and fermented milks, a way towards Indian perspective, probiotics for improving inflammatory stress and obesity, and commercial scope for fermented foods and beverages. And then we'll have open discussion session where all the questions asked by the participants will be answered by the speakers. Dr. J.B. Prajapati sir will act as a coordinator of this session. So I request all the participants to write your queries and questions in the chat box. We'll answer them during open discussion session. So first day of the webinar is going to be very informative, and I sincerely hope that everyone really finds this session useful. I'm sure the knowledge and deliberations will give us some important takeaways, which can be helpful to us to improve in our work field. So let us start with the very first speaker, Dr. Surajit Mandal. Sir is professor at Dairy Microbiology Department, West Bengal University of Animal and Fishery Science, Kolkata. And today he is going to talk on dairy starter culture and fermented milks, a way towards Indian perspective. Sir, please.
Is the presentation is visible?
Yes, sir. Make it
Yes,
full screen.
yes.
Huh?
Make it full screen.
Full screen, karo, full screen. Bas.
Okay.
Yes, it is okay. Now you start.
So good morning, one and all present here. Chairman, co-chairman of the station, coordinator, officials from Department of Biotechnology, BIOLAC, other fellow speaker, distinguished guest, and participants. Welcome to this presentation that cover the different aspects related to the dairy starter culture, that is the heart of fermentation, and fermented milk, a way towards Indian's perspective. So there is a very rapid growth in Indian fermented dairy product sector. Various types of products, either traditional or product from the Western origin, are penetrating in Indian dairy industry or market very rapidly. And it is a not the particularly today's activity, it is a age-old practice for preservation of excess milk, and also the greater sense that the excess foods for future use. During fermentation, what happened? Acidification due to the activities of starter culture, the rapid growth in the medium, and acid production leads to the fermentation and fermented dairy product and fermented foods. That acidic environment improve the shelf life, also improve the taste of the raw material. It is a product and have some health benefits, nutritional benefits. Nowadays, probiotic and therapeutic attributes, and also the nutritional advantage. It is well awarded among the consumer. And these are prepared by harmless bacterial population. Active microbial preparation is the starter culture, that is the heart of fermented foods, particularly the fermented dairy product. It is intentionally added, not only today, it is the age-old practice, and part of previous fermented batch or part of that particular fermented product, it is added to the fresh raw material for carry over the fermentation. Initiate the desirable change by the starter culture. Then overall, the major starter culture of dairy interest belongs to the lactic acid bacteria, particularly when they are metabolizing the sugar present in milk, that is the lactose, and major end product is the lactic acid. That's why these are lactic acid bacteria. The various important role play by dairy starter culture, that is the lactic acid bacteria, that is the fermentation of lactose to produce acid, and lactic acid decrease the pH of the milk, and curd set is there. That is the characteristic body and structure of the fermented product is there. Overall flavor and taste of the product, and low pH improve the shelf life of the product. Also the safety of the product. The desirable flavor, mainly the diacetyl, acetaldehyde, part of acetic acid, overall aroma and flavor of the fermented product. These are desirable for improving the sensory attributes Some people not prefer to drink milk, but prefer fermented product due to the good aroma and flavor. Carbon dioxide produced by the heterofermentative lactic acid bacteria. This is important. Some variety of the fermented product where the astringency or fizziness is required, particularly the cultured buttermilk, some acid alcoholic beverages, carbon dioxide is essential, and the eye formation, certain variety of the cheese, that is the texture improvement. Exopolysaccharides, that is the gum or the polysaccharide produced by certain group of or certain strains of microorganisms. Strains of microorganisms improve the texture of the product. As observed in fermentation or fermented product, that is the set card, if there is any over-acidification or any mechanical disturbance, that weighing off is there. Exopolysaccharide improve the texture of the product by holding the excess water, improving the mouthfeel also. And some of exopolysaccharide having some health beneficial attributes. That is the functional exopolysaccharide, bifunctional exopolysaccharide. Bacteriocin, that antimicrobial metabolites produced by lactic acid bacteria and other bacteria. The some certain strains of lactic acid bacteria produce the bacteriocin, and in situ production enhance the further shelf life of the fermented product and also the safety. That is the part of bioprotective culture. These are the type of starter culture used in fermented milk product. That is the mixed strain. That is the traditional backsloping approach. Unknown mixture of different lactic acid bacteria, those are desirable, and other certain undesirable microorganisms are also there, not taking part in fermentation. Particularly the traditional dahi, kefir, and artisanal variety of the cheese are manufactured. That is the mixed in starter culture. That is the part of previous days fermented product. Still, mixed in starter culture popularly used for preparation of certain variety of fermented dairy product. And defined strain starter, these are the lactic acid bacteria isolated from the mixed strain or traditional fermented product. Selection of particular strain, that is the characterized strains with well documented technological properties for use as a starter culture to have the better control in the fermentation. These are used either single microorganisms or sometimes paired microorganisms. Very popular that yogurt, that is the paired of S. thermophilus and Lactobacillus bulgaricus. Multiple strains, 4 or more strains. And whatever fermented dairy product maximum produced by the organized dairy industry, they are using the thermophilic, mesophilic brand, more than 4 and 5 type variety of different strains of lactic acid bacteria for getting the desirable fermentation. So these are the, in left column, various type of the product, fermented product. And in right, there are the combination of the culture. Yogurt, that is the paired culture. That lohi, lassi, that is the particular the multiple cultures are there. And obviously, the many strains are used in combination to get the desirable product. In Indian market, dahi, lassi, buttermilk, and also some part of the yogurt, these are very popular. Fermented probiotic milk with the Lactobacillus serota, that is the Yakult. Now, this is available in Indian market, having the gut health improvement and immunity development. And other cheeses and kefirs and certain type of product, also they are manufacturing in Indian conditions, but their quantity is less. The novel starter culture, the searching of starter culture beyond the primary function of acidification and flavor production. If it is endued with the lactose production activity, EPS activity, good galactose utilization, having the benefit in the fermented dairy product preparation. And these are the defined attributes of the functionality for getting the different type of the benefit, particularly the proteolytic activity leads to the better cheese ripening and also the bioactive peptides having some beneficial attributes. So now what are lactic acid bacteria? So they are either cocci or rot itself, non-spore forming, fermentative in nature. Well, example, devoid of respiratory energy generation, metabolic process. That is the respiration. They are microaerobic, though they are not using the oxygen, but able to grow in presence of oxygen. But lesser the oxygen content, better their performance. And lactic acid is the major end product. That's why these are called the lactic acid bacteria. Because these properties are essential when we are talking about the preparation of defined culture, isolation of the culture, characterization of the culture. The first requirement is there that gram positive, catalase negative, pure cocci or rot, obviously, and lactic acid production ability. So these are the type of microorganism, obviously, either spherical shape or cylindrical shapes are there. Homofermentative, heterofermentative, either produce only lactic acid or lactic acid with other metabolite, acetic acid, carbon dioxide, ethanol. It is there. Mesophilic and thermophilic. Here, the mesophilic and thermophilic definition of the lactic acid bacteria somehow different from the food microbiology. For mesophilic lactic acid bacteria, 25 or 20 to 30 degrees centigrade, they are optimum. And thermophilic, 40 to 45 degrees centigrade. Mesophilic, 20 to 30 degree, average 25 degrees centigrade. Thermophilic, 40 to 45 degrees centigrade, average 42 degrees centigrade for their optimum growth. The mesophilic culture application, some different type of the product, thermophilic having that, and they are slow. They are fast, their growth and cut-setting acid production. The citric acid, positive or negative, it is having the importance of diacetyl production. It is there. They are acidophilic in nature, salt tolerating, and also some of the heat tolerating properties essential for preparation of certain variant of the dairy product, particularly the cheeses. These are the major pieces already we have listed in different fermented products. These are the cocci category. These are the rot category microorganisms. In cocci, there are lactococcus. These are the white, the major starter culture. This is the major starter culture of that. And along with leuconostoc. And another one of the streptococcus, this is also the major. And combined with the rot bacteria. So then the starter culture is formulated for permutation and combination of these particular cultures for getting their better metabolic activities. Because when the streptococcus, thermophilus or lactobacillus delbrueckii, so they are grow separately or used as a starter culture separately, their growth is or acidification activity not so much. When they are combined together to have the yogurt culture, their associative growth or symbiotic nature, that faster acidification and better product quality with body structure and flavor observed. So next, the preservation, maintenance and propagation of dairy starter culture. So these are particularly the traditional practice, but now the advanced industrial practice, this is not followed. That use the direct vat starter culture, that is the concentrated starter culture is used directly in the production vat without further subculturing and propagation and preservation. Simply open the sachet as per the follow the instruction from the manufacturing industry and application of the starter culture. So then without any subculturing, preservation or maintenance, so that fermented product is prepared. That is very easy. But availability of that particular culture. Now in Indian market, various players are there, and major player already we have particularly come across that CHR Hansen is a major player, and with the other players are there, Indian players are also there. So that is the devious part. But when we are talking about the R&D, that laboratory for preparation of starter culture, defined starter culture, preparation of technology for the devious culture, so then we need to follow this as a regular microbiological laboratory practice for preservation of the culture, for preservation of the culture for future use. So this is the long-term preservation, short-term preservation. Long-term preservation, that application of the low temperature, that is the liquid nitrogen minus 70 degrees centigrade is the other way that applying the freeze drying. So then culture preservation can be more than 10 years. And freeze drying is the widely used technique for long-term laboratory scale preservation of the microbial chair by lyophilization. Then propagation of the preserved culture. Once we are getting the freeze dried culture or lyophilized culture, then we have to activate the culture. This is the particularly traditional. Before the devious culture came in market, this practice was there. The activation of the culture, preparation of the mother culture, stock culture, mother culture, feeder culture, bulk culture, and that bulk culture is used for the inoculation of the fermentation fat. So this is the step. This is the production fat. The milk is there. This is the bulk culture. The bulk culture is added. Then gradually, from the around 0.1 gram culture, then it improves that. So that is the different type of the propagation facilities have been developed. So now it is not in practice, but some products still they are produced better using the liquid culture. So this is particularly the step for preparation of the propagation of the culture. Reconstituted skim milk powder or powder skim milk is used, heat treated, cooling, inoculation with the active culture, and incubation. Incubation to get the desirable number of the organism. Normally the inoculation rate is around 10 to the 6 to 10 to the 7 CFU. That is the bacterial cell or the coloniform unit per ml of the medium. And when the culture is ready, around 10 to the 8 to 10 to the 9 CFU per ml or gram of the culture is there. So that culture is ready. After the culture is ready, if it is not used, then for short-term preservation, 5 to 7 degrees centigrade. Around 5 to 10 days we can preserve. After that, if we interested to preparation of the culture, so that is the Lactococcus lactis or Lactococcus culture. This belongs to the mesophilic group of the bacteria. So then obviously the first preparation is similar to all, and second is the cooling as per their incubation temperature, inoculation with active culture, and it takes the more time to set, around 12 to 15 or 18 hours, and after that the cooling if it is not immediately used for future application. So the effectiveness of bulk culture, then obviously the quality of milk. Then obviously the quality of milk is important. Then that quality of milk, mainly the antibiotic, presence of the antibiotic, it can hamper the bacterial growth. Then sometimes the antibiotic can come as a contaminant from the animal, milk animal to milk. So then testing of antibiotic, it is very, very essential. Then antibiotic free, non-fat dry milk is suitable for the preparation of the starter culture. The proper ripening or incubation, then over incubation not desirable. During the over incubation, obviously. So there may be the chance of loss of activity. But technological traits, mainly the acid production activity, flavor production, proteolytic activity, DPH activity, because most of the or technological attributes of the lactic acid bacteria, they are related to the plasmid, that is the extra chromosomal circular self-replicating DNA. So then, if there is any adverse condition, either related to the quality of milk or during the preparation of starter culture, there is the incubation and also the after incubation, that the storage, it is important. So if there is any type of the environmental adverse effect, so there may be the chance. Then proper storage is there and immediate cooling. It is essential. The next is the rotation of the culture. The same culture, particularly Lactobacillus lactis. So there are various strains are there. The same culture, that is the Lactobacillus lactis, subspecies lactis, various strains are there. So they are used in a rotation, particularly the prevention of the bacteriophage, that is the virus of the bacteria. Then one strain is unrelated to the bacteriophage. So then if one strain is attacked by the bacteriophage, then other strain is introduced. So then that strain will not be affected by the bacteriophage. Then if it is rotated 4-5 culture, in particularly that one, so then obviously so there is a chance of decrease in the phage buildup and phage related culture innovation activity. So this is particularly the overview of a large scale production preservation of the starter culture. So it is the either liquid starter culture, immediately it is used, or concentrated starter culture. Concentrated starter culture, either fusion concentrate or freeze drying. So then concentrated starter culture, the concentration after preparation of the starter culture, so they are around 10 to the power 8, 10 to the power 9. So then after that, the further concentration is improved by centrifugation or ultrafiltration, that is removing of the medium, or the culture is concentrated. After that, it is preserved. That is the freeze drying or the quick freezing technique, the frozen concentrate in a standardized medium, that is the having the cryoprotective media. That cryoprotective agent will improve the survivability of the cell during either quick freezing or freeze drying. That is the freezing followed by drying under vacuum in lyophilization process. So this is particularly the overview of a bioprocess for lactic culture. So then optimization of this stage, that is the culturing process. Obviously, it will be a control condition in a fermenter. And first, the laboratory scale fermenter, then followed by the pilot or production scale. The optimization will be there. Optimization of the media, formulation of the media, that is the food grade media. It is important. So then batch culture or fed batch culture for getting the better performance. And when the culture is ready, so the culture is harvested early stationary phase. The cultures are in mature state, that is having the good preservation capacity or better performance after preservation is there. So then concentration by microfiltration followed by harvesting the cell by refrigerated centrifugation. So then cell mass in drying medium. So drying, maybe the spray drying is also there, or vacuum drying or freeze drying, general freeze drying. So then two types of the drying media, that is the heat protective media and cryoprotective media is there. Then ultimately the end result is the concentrated culture in the powder form. So it is better, particularly shelf life or preservation or volume is less. So then after that, so that particularly the biomass rich powder or active culture, so can be used for fermented dairy products. And by applying this same process, then concentrated probiotic biomass can also be prepared. That can be as a starter culture or supplementation in various products for preparation of probiotic functional dairy or food product. It is there. So this is the story related to the Indian production of dairy starter culture. So this is the Avisource Biologics, a Pune-based industry. So they have source the starter culture technology from ICR NDRI Karnal, and they have created a pilot scale facility for preparation of DVS starter culture. They are manufacturing the various type of the array of starter culture related to the fermented product, the dahi, yogurt, shikhand, chach, and marketed. That cultures are in Indian market. The efficiency is in the Indian market. So next, the quality control of a dairy starter culture. The two types of culture we have come across, that is the propagated culture. Another one is the preserved concentrated culture. That is the DVS or DVI. So what the cultures we have need to evaluate their quality, their purity, their activity for getting the better result. Vis-a-vis, when we are talking about their R&D, either in particularly the culture production industry or R&D in particularly the research laboratory, so then we need to do this type of the test to ascertain the quality of the culture before it will be applicable or applied to the preparation of either commercial scale or laboratory scale fermented dairy product. Then obviously the purity test, culture should be pure. Either cocci or particularly the bacilli, lactic acid bacteria will be there. The microscopic examination, morphology, gram-strength behavior, catalyst test, already we have said lactic acid bacteria or the catalyst negative. The coliform and yeast and molds. Then during preparation of the starter culture, so there may be the source of the contamination, then it will be free from coliform and also the yeast and mold. Coliform, there is a hygienic indicator, and the yeast and mold, particularly these are important in fermented dairy product because they are the major spoilage organism of fermented dairy. If the culture is loaded with the yeast and mold, then shelf life of that particular product prepared with that particular culture will be less. And it is observed during the batch sloughing, that is repeated subculturing, using the same batch, particularly the dahi. So then if that dahi is contaminated with yeast and mold, then obviously the batch shelf life and quality of the product. And this is the activity test. Then acidity, obviously the rapid acidification or faster acidification is desirable. Flavor production, that either the diacetyl or the acetaldehyde production, how it can be tested. This is the process. Then when we are talking about the isolation of the diacetyl producing organism, then we have to follow that. If there is intense pink color, this indicates the positive. So then this is the good culture. This is the flavor producing culture. So again, the acetaldehyde. The acetaldehyde is a major flavoring compound of yogurt. Then after testing this, if the intense blue color is there, so that indicates the sufficient acetaldehyde production by the culture. Then obviously we have to ensure that when we are selecting the yogurt culture, so then this positive test is essential for that particular bacteria. Another one is the acid production. There is the horalelical activity test. So mainly this is applicable for mesophilic culture, mainly the Lactococcus lactis. So by applying this test, this is the process, how it is done. That the 3% culture and particularly the 37.7 degrees centigrade, that is our mainly the body temperature type temperature. So after 3.5 hours, the activity ratings are there. Then based on their titral acidity. If developed acidity is more than 0.4, that is the good or fast culture and suitable for preparation of the cheese, mainly the cheddar cheese culture, or mesophilic culture for preparation of other fermented dairy product, dahi or particularly the cultured buttermilk, it is there. So this situation, particularly the slow culture or intermediate, and this is very less culture. So then when we are isolating the bacteria, so then we have to categorize by applying this test for their better application in starter culture formulation. The concentrated culture, these are the tests. Concentrated culture, that is the devious culture. So these are the particularly tests. Then when we are receiving, so the shelf life of the product according to specification by the industry, their direction. Package, obviously the integrity level information, it is essential. The viable cell number, it is may be declared, or they are particularly the dose, that this much powder is suitable for preparation of this much quantity of the drug. So then obviously the viable number is important. Then absence of any contaminant pathogens or extraneous matter, and acid production and other functional attributes obviously essential in preserved culture, so that we can get the better quality fermented product. So these are the specification normally follow for quality evaluation. This is important at production industry where the starter culture is produced. Then this is the quality control check. Or when we are talking about the R&D for preparation of any concentrated freeze-dried or spray-dried culture for direct VAT application or technology development, then we have to follow this test for evaluation of the culture. Because if the quantity of powder is there, but the viable count, if it is there, decrease some any condition due to storage or other condition, then obviously that specification only be that will be applicable when this number is that. If their concentration is decreased, then that particular quantity will not be sufficient for preparation of that quantity of fermented milk as prescribed. So sometimes the slowness of the batch is there. So there may be the defined region, because we are getting that particularly the 100 liter milk is there, then we are giving the 10 gram or 20 gram sachet. Then if their viable activity or particularly active culture is less, so then fermentation duration will be increased. Then one traditional product, there is the Mishti Dahi. I think so. This particularly is not very popular in all the over the India, but it is very popular in the eastern part of India. Like West Bengal, Assam, Jharkhand, Bihar. So this Mishti Dahi is there. The dahi added with the high quantity of the sugar, as high as more than 20% or around 20% sugar. So these are the two cultures has been studied for preparation of freeze-dried culture for direct addition for preparation of Mishti Dahi. So this is the viable count. Then obviously it is the devious. Two media. One is the wave-based media that is developed at the laboratory, and M17 media, that is the normal culturing media for this organism, that is the Streptococcus thermophilus. These are the two strain or two NCDC number organism, both are Streptococcus thermophilus. So then suitability, how to evaluate the fresh culture, 2%. When 100 gram, 2 gram culture is there. If 1 liter, 20 gram culture is there. So then for devious, then it is very less quantity, because number of the viable cell is high as compared to here. So this is the process for standardized production of the Mishti Dahi. So 15% sugar is there. The tested that culture can tolerate up to 18% of the sugar. But for Mishti Dahi preparation, more than 20% sugar is added sometimes. Then this culture may not be suitable for field, but up to 18% this culture is suitable. This is the generic process, standardized process, that laboratory level preparation or evaluation of the culture. So this is the observation. Obviously, fresh culture is faster and concentrated culture. So this somehow slower. The pH all are equal and total viable load are equal. So these are particularly good concentrated culture, 15 to 16%. So then it can form the card around 7 hours, 7 to 8 hours.
So Rajesh, sir, sorry to disturb you, but sir, kindly wind up your session within 5 minutes, because we have
I will
to
take
complete.
around 1 minute to complete. Madam?
Okay, sir.
So
Okay.
this is particularly the culture, it is available at NDRI, and this particularly in the form of the transfer of technology, this culture has transferred to several industries. Now the industry are prepared, the distillery, then widely for the prominent producer, that is the Namaste India Limited, Kanpur based company. They are preparing this with this culture, and this biophosphorus also so there. So for preparation of large scale biophosphorus that is available with that. So thank you one and all, and also the organizer to give my opportunity and invite me to present in the area of the
Thank-
starter culture and also the laboratory activity that is also developed at NDRI, Karnam. Thank you.
Thank you so much, sir, for sharing the presentation. It was really very informative. You covered all the basic concepts and you connected with the Indian perspective also. So thank you. Thank you so much, sir. Moving ahead, our next
you.
speaker is Dr. Kanti Kiran Kondepudi, sir. He is scientist E and group leader, Healthy Gut Research Group at National Agri-Food Business Food Biotechnology Institute, Nabi, Punjab. And today, sir is going to talk on probiotics for improving inflammatory stress under obesity.
Can I get the link for sharing?
Dr. Sujit,
I'm making
can
the,
you make him?
yes, I'm making the presentation. Just give me a second. So you can present now, sir. Okay, sir, you can present. You are the presenter now, yeah.
So can you see my slides in the full mode?
Yes, sir, yes.
Yes, sir.
Yes, we can go, yeah.
Okay. So for my convenience, I am just turning off my video camera. And
Okay,
then I
okay,
will-
sir, no problem.
So very good morning to all of you. And first of all, I would like to thank the organizers, especially BIRAT team, Dr. Sujit, and my friend Dr. Subrata for giving me this opportunity to share our research on probiotics. So Dr. Sujit, you can stop me whenever you feel that my time is over.
Sure, sir, we'll do.
I will take around 30 to 40 minutes to complete my presentation, but if you feel you have to stop, you stop me. Okay, right? So
Sure, sir, sure.
myself is Kanti. I'm working as a scientist in the National Agri-Food Biotechnology Institute, which is located in Mohali. So these are the contents of my talk. I will be talking about probiotics for improving the inflammatory stress under obesity. And so I will be discussing about probiotics and prebiotics, what is obesity in relation with the gut microbes. And then I will briefly describe about what research we are doing at Nabi. So we all know that probiotics, I'm not going to give much introduction about it. Probiotics are the live microorganisms, but the key is you have to have a health promoting effect when one consumes it in a sufficient quantities. On the other side, prebiotics or the or the non-digestible carbohydrates. Nowadays, the scope of prebiotics has been expanded, and polyphenols and anything that promotes the commensal gut bacteria comes under a prebiotic category. So the combination of the probiotics and prebiotics is called the symbiotics. That means the 1 + 1 must be more than 2. That means when you combine probiotic and a prebiotic, the effect of the formulation or the combination should be much more higher than the individual entities. So when we talk about the probiotics, so it is all because of tremendous market search and market potential. So there is a great buzz about probiotics. And as you see here, this is on the left side of the slide, this is the world probiotics market value, which is projected to 7.35% CAGR by the end of 2026 and worth of 75.9 billions. And coming to the Indian scenario, so we are still in the infancy, in the market value of the in tapping the market potential of the probiotics. And we have the projection to grow at around 13.56 to reach to the market size by the end of 2025. So the key drivers, as was mentioned by Dr. Jaina in his introductory remarks, that COVID has taught us enhancing the immunity. So there is a great surge in immune enhancing food products. So probiotics majorly constitute immune enhancement. So there is a tremendous market value and affordability, and importantly, there is a link between probiotic consumption and improving the health, which is based on the diet. It is not like pharma preparations. So on the top side or top of the slide, you see there are a lot of probiotic products in the European market. They are all flooded with tremendous amounts of dairy, non-dairy based probiotics and pharma supplements. However, in India, we are now in the stage we are making some kind of probiotic products. However, the major players are the Yakult and Danone. Although Amul supplies or manufactures the probiotic based dahi, but most of the strains they procure are from the foreign agencies. So making it a need for Indian probiotic strains that could improve the human health of our population. So linking probiotics with the health. So the major buzz around right across the globe is obesity, which is one of the leading causes of death, which can be preventable after obesity is next to smoking. So this causes so many lethalities, and which is characterized by excess body fat that increases the risk of other health problems. So this is from the hunter-gatherer stage. This is how the humans used to appear, their physique, and this is the present day scenario where we are seeing the weight of the population or the population of the country is being tremendously increased. So obesity, as I said, is a risk factor for many other comorbidities like type 2 diabetes, insulin resistance, fatty liver, several cardiomyopathies, respiratory disorders, eating disorders. So it is expected that 1.9 billion individuals all over the world, this was the calculation that, so this is the graphical representation of that, and you can see here each and every state where the predominance of obesity and overweight is high or indicated in red here. So why obesity is an important disease to be worked out, and why there should be preventive strategies? Because obesity, as I said already, it is associated with other comorbidities, and there are several factors which can influence that. The primary factors being the genetic and lifestyle and environmental factors, and diet and food recently has been shown to modulate the gut microbiome, and then it can be one of the causal factors for obesity, or it can also be converted into a factor that can prevent the obesity. So what happens in obesity? Obesity is accumulation of the fat not only near the abdomen, but the excess of fat that is accumulated is transferred to various tissues like liver, kidney, brain, etc. And it leads to inflammation in those and leads to various health complications. So when I said that diet is also one of the contributing factors for the obesity, so what will happen when the diets which are rich in refined sugars and high saturated fats, it goes into the intestine and destabilizes the intestine and the intestinal microbial atmosphere. So there is a alteration of the microbial composition with more amount of pathogenic bacteria in the gut and less amount of commensal bacteria in the gut, which is termed as dysbiosis. So under this condition, the microbes which are pathogenic in nature, they themselves travel through the gaps between the intestinal cells. They interact with the immune cells, and then they go into blood circulation and reaches various organs and cause inflammation. So one of the bacterial metabolite that has been shown to be related with the leaky gut phenomena and endotoxemia and inflammation is the lipopolysaccharides, which travels through the intestinal membranes and reaches to almost all organs. And then it leads to increase of inflammatory markers like IL-1 beta, IL-18, and as well as it reaches the adipose tissue and other peripheral tissues in the body, going into the brain, pancreas, and then it also causes many of the health related issues. So when there is a dysbiosis in the gut bacteria, it also causes dysbiosis in the bacterial metabolites. So our gut bacteria produce many useful metabolites such as short chain fatty acids, neurotransmitters like 5-hydroxytryptamine, and then gamma aminobutyric acid. These will also get deranged, and it leads to many of the health related issues. So that's why it is important, like, to have a balanced microbial atmosphere in the gut. So one of the ways that we can achieve the intestinal homeostasis of the good commensal bacteria is by manipulating the diets. So diets which are having high dietary fiber, high polyunsaturated fatty acid content, and other proteins, bioactive peptides and proteins that enhances the commensal gut bacteria. So our group is actively working on development of multiple strains combination of probiotic bacteria and non-digestible carbohydrates as symbiotic supplements for overcoming the metabolic syndrome. So we have been prioritizing various anti-inflammatory probiotics. That means which is the bacteria toxin. So as I said, diet shapes the microbiome composition. When you eat a unhealthy diet rich in saturated fats, and then we have also measured whether this causes the modulate the glucose homeostasis, because when we give animals when we feed the animals with a high fat diet, it significantly impairs the glucose homeostasis. That means you will have high fasting levels of the glucose, as you see here. So we have performed OGTT just before the termination of the experiment, and the fasting animals had higher blood glucose level, and when we give a time course of the oral glucose tolerance, the high fat fed animals had highest shoot of glucose in the blood, whereas the bacteria, whereas the animals that are co-fed with the high fat diet along with the Bifidobacterium brevi, they have the low levels of the glucose in the blood, which indicates that this bacteria modulates beneficially the glucose homeostasis and reduces the insulin resistance. So this figure indicates the insulin tolerance test. So insulin tolerance test is an indication of the insulin sensitivity. When you give insulin, whether the sugar level goes down or not. So high fat fed animals, when you give insulin, they have still higher glucose levels in the blood. But the bacterium fed along with the high fat diet into the animals, you see there is a reduction, significant reduction in the glucose levels, indicating that the animals which are co-treated with Bifidobacterium strains has enhanced insulin sensitivity and less insulin resistant. That means they are less prone to type 2 diabetes. So we have also shown the similar results with the pyruvate tolerance test. And then we have seen that in the blood, there is a significant improvement in the cholesterol levels. High fat leads to a significant accumulation of the cholesterols in the serum, whereas the bacterium fed has low amounts of cholesterol. The good part of it is they have high levels of HDL cholesterol, which is considered as the good cholesterol. However, we have not seen there is no significant difference in the low density cholesterols. And we have seen whether the various peripheral tissues are suffered from the inflammation and oxidative stress. We have examined the amounts of melanoidin oxygen species. So there is no reactive oxygen species in the Bifidobacterium fed animals, as you see in the liver as well as in the white adipose tissue. And the same results for the glutathione. Reduced glutathione is an indicator for reduced oxidative stress. So there is no oxidative stress in the animals that are co-fed with high fat diet as well as with the Bifidobacterium strains. And we have analyzed in the fecal matter whether the bacterial feeding causes any changes in the levels of the short chain fatty acids. So as we have seen that there is a significant improvement in the short chain fatty acid levels of acetate. However, we did not see much change in the propionate and butyric acid levels. However, we have seen that there is a slight enhancement of the butyric acid and propionic acid levels as well. So this study indicates that the Bifidobacterium supplementation prevents obesity And some of the effects are maybe due to modulation of the gut microbiota, which we are currently analyzing. However, we have seen that there is a significant reduction of inflammation and body fat accumulation. In partly, these effects are maybe due to the improved production of the short chain fatty acids. So in the case of the lactobacillus strains, we have studied the in vitro studies, as I said earlier. In the in vivo studies also, we have infected the animals with LPS, and we have seen that there is a significant derangements in the gut microbial composition. There is a significant production of the pro-inflammatory cytokines in the gut. However, when these animals are co-fed with lipopolysaccharide and the lactic acid producing bacteria, there is a significant reduction in the inflammation. So we have published these results recently in the Frontiers in Microbiology. And in another study, we have shown that Lactobacillus pentosus strain in combination with isomalto-oligosaccharide exerted better improvements from obesity and metabolic syndrome compared to the individual strain or isomalto-oligosaccharides in separation. However, when we have combined both of them and fed to the animals along with the high-fat diet, there is a significant reduction in the steatosis, liver injury, as well as adiposity and oxidative stress in the adipose tissue, and it promotes the growth of healthy gut bacteria, especially the lactobacillus and bifidobacterium strains, along with the reduction in TLR4 signaling and tight junction protein destabilization. We have also seen in the serum that the combination of isomalto-oligosaccharides along with the lactobacillus strains prevents the dyslipidemia as well. So this study also we have published in the scientific reports. Right now we are working on combination of the lactobacillus strains and the bifidobacterium strains along with isomalto-oligosaccharides. So the disease model is again a metabolic disease model, but the model what we have chosen is more or less do not promote the weight gain, but it reduces the weight gain, because in this model we have hypothesized that Indian diets have low proteins, and even though there are some people who are lean, but they are still metabolic, they're suffering from the metabolic diseases. So we want to reduce the protein and see whether it induces any metabolic syndrome, even if you have a high fat diet and high refined sugar. To our surprise, we have noticed that when you feed the animal with a diet which has low protein but high fat and high sucrose, instead of promoting the weight, it is decreasing the weight gain due to protein leverage hypothesis. So there is a reduction in the weight gain. So we are expecting that this diet model will be suitable model for those who are non-obese, but they are metabolically challenging. So this model we have adopted, and we have given all the bacterial strains in combination with isomalto-oligosaccharides, and we have seen that there is a significant prevention in the loss of weight, as you see in these various intervention groups. And we have also excised the colon, and we have seen that there is, in the low protein diet, there is a significant impairment in the colonic structure and colonic length, which was restored in the symbiotic, where the colons are looking much healthier, equal to the control animals than to the normal symbiotic fed, low protein, moderate fat fed animals. So there are some morphometric parameters. We have seen the high blood pressure in the low protein group. The blood pressure is getting improved in the mice that are fed with this symbiotic supplement. There is a high level of insulin here. You see that indicates insulin resistance, leptin resistance, and there is a significant impairment of anti-inflammatory adiponectin, which is released from the adipose tissue. And there is a high amount of lipopolysaccharide, which is an endotoxin that is produced in the gut due to gut bacterial dysbiosis. So all these factors are getting bettered when we give a symbiotic blend to the animals along with the disease diet. So this is also like oral glucose tolerance. There is a significant impairment in the glucose homeostasis, which is getting improved when we give these bacterial treatments. And then there is a significant reduction in the inflammatory markers, as you see here: interferon gamma, C-reactive proteins, TNF alpha, IL-6, etc. So this slide shows you the effects on the liver. Low protein diet causes significant deposition of the fat in the liver. So again, the hypothesis is working out to be better for us because we predicted that low protein diet is the main cause for increasing fat deposition and non-alcoholic fatty liver or fatty liver even in the normal population. So you see here there is a significant deposition of the lipids here. In the symbiotic fed mice, you see there is a significant improvement. This liver of these animals which are fed with symbiotic is as good as the control animals. And you see here there is a huge deformation in the liver structure, in the number of fat cells is higher in the liver, which are all getting better when we give the symbiotic treatment along with improved inflammatory markers. One important thing I want to mention here in this symbiotic blend treatment increased the anti-inflammatory capacity, as we see IL-10 secretion is enhanced in the symbiotic treated mice. So as I have told you earlier, we have filed a couple of patents and this patent is under final stages. We are waiting for the National Biodiversity Authority's approval for the patent to be granted. And then this patent we have submitted in 2022, which is under progress. So you have seen here the same thing when we fed with the low fat, moderate fat and low protein diet. You see there is a significant impairment in the colonic architecture. There is a significant deposition of the inflammatory markers. There is a significant loss of goblet cells which produce the mucin. But however, when we treat with the symbiotic supplement, there is a significant improvement in the intestinal parameters as well. So this is the graphical representation of the neutrophil infiltration, which is a marker of enhanced inflammation in the intestine, while symbiotic supplementation prevented them. And there is also other changes like number of goblet cells is decreased, which is again a quantification of the histological data I have represented here. So significantly, there is a higher histological score. That means higher impairment of the intestinal function, whereas symbiotic supplementation prevented these changes. So we hypothesize that the bacterial supplementation in the form of symbiotics prevented the dysbiosis in the gut, which leads to reduced levels of LPS. And when there is a reduced levels of LPS, there is a low load of LPS in the circulation, and then there is low load in the tissues as well. That is responsible for reduction of inflammation under dysbiotic conditions. And this is also we have seen in the ileum. You can see there is a significant impairment in the ileum structures here, but symbiotic supplement is restoring all these negative effects of the low protein, moderate fat diets. And we have estimated the abundance of selected gut bacteria through real-time quantitative PCR. So bacteroidetes has been significantly increased, which is again a good marker for a healthy gut, whilst Firmicutes level has been significantly decreased. These two, the ratio between bacteroidetes and Firmicutes should be high in a healthy population. So this symbiotic supplementation is increasing the bacteroidetes to Firmicutes ratio, along with increasing the abundance of commensal bacteria like Lactobacillus, Bifidobacteria, and most importantly, Akkermansia and Prevotella faecalibacterium. So all these bacteria we have selected based on the literature. We have quantified them through RT-PCR, and we found that these abundances of these bacteria has been significantly improved, and we feed the animals with the symbiotics. And on the last row, you see the abundance of the bacteria which are belonging to pathogenic groups like E. coli, Enterobacteriaceae, Klebsiella, and Salmonella, which are majorly gram-negative bacteria, and that produces lipopolysaccharides, which is the endotoxin. There is a significant decrease in the levels of this bacteria. And we have seen that symbiotic supplementation enhanced the production of the short-chain fatty acids. Again, total short-chain fatty acids have been significantly improved, and the seen changes are partly maybe because of the improved short-chain fatty acid production. So that's all I have for the right now. And to summarize this study, so probiotics play an important role. So probiotics, although they are lucrative in terms of market value, so that means we have a lot of market potential. However, because of the hasteness to enhance the marketing strategy for the probiotics, the good science is being impaired. So because of that commercial interest, there are so many Dubois products are being flooded into the probiotic market, which is killing the science of probiotics. And then now and then you see the headings like probiotics are useless, probiotics are nothing, they don't do anything. However, we need to understand each and every characteristic of probiotic and the function of the probiotic or strain dependent, and each strain has to be analyzed carefully for their desired attributes. It is not like one magic bullet for all the diseases, because you see in the market there are products and some of the people do jump on them and then they do testing and then they say they are inefficient. So this should not be the case. When you are making the combinations as multi-strains or symbiotics, one has to carefully understand the science behind this before we hit into the market strategies. That's what I want to just say and conclude this. And this is my institute, where it is located. This is National Agri-Food Biotechnology Institute, beautiful institute, which is a green campus located in Mohali. And if any of you are interested to do any kind of research, especially those who are students, please visit our website and see what kind of research we are doing. So this institute catalyzes both agriculture, food, and nutrition. So we produce nutritious food by various genetic breeding and genome editing approaches. And that nutritious food we are testing whether they are suitable for healthy nutrition or not. So if any of you are interested to travel along with us in this journey, please do come to the NABI and start your research careers here. And finally, I would like to thank the funding agencies, our own organization, NABI, then DBT, NER, BPMC, then DST, ICMR for providing us research grants. And especially, I would like to once again thank the organizers, especially Dr. Subrata, Dr. Sujit, Dr. Srija, for giving me this opportunity to discuss about the probiotics. And I'm also thankful to my collaborators at NABI, Dr. Mahendra, and my external collaborators, Dr. Subrata, Dr. Badada, and other people from various institutes in and around NABI. And these are my students. They are currently all of these I have presented the work that has been done by all these students, and all of them are doing postdocs in US and Europe. And Shashank is working as a scientist in a medical college. And with this, I would like to end my talk and thank you everyone for your patient listening. And I would like to take any questions in the end.
Thank you so much, sir, for sharing the practical knowledge and your research studies in very detail, which shows the benefit of consuming probiotics in reduction of inflammation in obesity. Thank you so much, sir.
Thank you.
Our next speaker is from industry, Mr. Sumit Saha. He is Business Development Manager at Christian Hansen, India. And I invite you, sir, to share your expertise on commercial scope of fermented foods and beverages. Sumit Saha, sir. Kindly
Yes,
start
am
your
I audible?
presentation.
Yes,
Screens
sir.
are visible, madam?
Yes, yes.
Yes, sir.
Yeah.
May
Okay.
we-
Actually,
Yes,
what I will do, I will shuttle between two slides because there are some examples. Ensuring the presentation it will come up, and I could not. I am not smart enough for that sort of sophistication in PowerPoint presentation. So for that, I have done that way. Okay. Okay. Good afternoon, everyone. First of all, thank you, all the members of the organizing committee and Dr. Hathi for organizing this session and inviting me. And it's really an honor to be here. So my session today would compose of mainly 3 points. First is to make you think, or give you a trigger to think about entrepreneurship in the scope of fermented food and beverages in India. Second, I would talk about the context. Why I am triggering you now. That's context. And number 3, how some product ideations. These are basic structure of my talk today. So first, I will go with the with a video. Let me know whether the audio is audible or not. Audio is audible?
No, audio is not audible.
Okay. I mean, we
So
can.
how can I?
It is audible for me.
Your voice is audible, audio is not audible. Your voice is audible.
You can hear, I think, Dr. Sumit.
नहीं वो जो वीडियो चल रहा है उसका
You can
Okay,
explain.
okay. The video will answer, right? Sorry.
You
The video, the
explain
audio,
and
video that you
make
played
your
for us.
slide. 1 minute, Sujit. Make your slide full screen. Come to the bottom. Yes. Now it is okay. But the voice is not coming. You can explain or you can work on this one.
Audible now?
No,
Hello?
no, it is not audible. Your voice is audible. You are very much audible.
Yeah, you can explain in the meantime.
Okay, you can
Explain what-
just see it, what it is. It is written. It is written.
Okay.
You can go. The thing is, FMCG sectors is undergoing from real GDP growth. This is in real terms. This is 2007 to 2023 CAGR. And the CAGR is getting dipped in 2017 to 2023 level. The major factors, in demonetization, GST, and COVID. That's for the later part of 2017 to 2023. So one of the most important reasons, lack of innovation and category development. That I will give focus into. And companies choosing margin expansion over revenue growth. That's a short-term view. To tame inflationary pressures, companies are actually doing the undercutting. The SKU sizes are getting rationalized to be in a perfect price point. That's what is happening in FMCG mostly. And second is lack of category development. And it's enough, I think. It's not working. So from previous slide, what we see, the one point is, most important points are lack of innovation and category development. And the type of innovation we have been observing in FMCG, food and beverage particular, is either efficiency seeking innovation or very simple value addition. Very simple value addition. And efficiency seeking value additions is like supply chain optimization, like automation, like design to achieve economies of scale, or production scheduling, etc., etc. And simple value addition is simply like Hindustan Lever's tea, say for example, tulsi flavored tea. Then it becomes ginger tea. Then it becomes lemon tea. Then it becomes ashwagandha tea. In the time of COVID, I have also observed that some players in South India, they have launched a product, ice cream, based on the flavor of ashwagandha. Now you just imagine how the mind of the innovator is, And next, you can, I can give you example on like, say, for example, flavored milk. Flavored milk, in the case of flavored milk, you can see the flavors are getting changed, like haldi milk, ginger milk, then ashwagandha milk. What they actually do, they actually end up doing, being the brand ambassador of these commodities, where their sales does not change too much, but the commodities are getting more focus and they become more in demand. Okay, so that sort of innovation, which is not actual disruptive innovation, which is making these one of the causal factors of making the FMCG more sluggish. Now, what are the factors? The major factors which is cumulatively changing or morphing the global food or beverage and or altogether in the dairy industry. These are the major forces I will talk about one by one. New business and operating models. Now, this is new business. Now, one of the point is globalization. Now, globalization as per me is simply means that you have access to global resources to get your product or services done. Now, one example is an artisanal cheese maker from a remote village of Nepal. One day calls me requesting with a query for a certain strain which I even don't know. That's globalization. I am from C.H.R. Hansen. The strain he is asking about, I have to go to the strain bank and search in the internet and have to find to answer his query. Second is scientists are now from Denmark as conducting trials for coffee fermentation in Chikmagalur. So this is globalization. Okay. Consumers on internet. Consumers, you understand this point more than me because COVID has accelerated this shift in a very profound way. The shift has happened more in Indian villages than in urban cities. That means the growth rate in internalization, digitization, has been more accelerated in rural format than in urban format in last 5 years. Then optimizing processes and new technologies. Optimizing processes, Dr. Surojit told about from starter culture to DVS culture. So that phenomena we have observed in dairy industry. The same I am observing in brewing industry, where previously they have the brewing houses or brewing companies who makes beer and wine, they have their own yeast propagation units. Now they are slowly shifting to this direct dry yeast solutions. Okay, so these things are one of the causal factors and morphing the new industries. Next is food safety and health concerns. Now countries are becoming more and more urbanized, and city population is growing by 65 million every year from a data from a McKinsey research recent. 2.5 billion people would live in Asian cities by 2025. That half of the world's urbanized population will be there. That means in Asian cities. Now, with urban life comes the side effects thereof, right? So, rising obesity levels and health concerns comes, diabetic epidemics comes, right? Now when your citizen becomes susceptible health-wise, then regulatory bodies like FSSAI comes to showcase their role. Now they impose regulations, and we see labeling in food products like low alcohol beer, alcohol-free beer, clean label, non-dairy, sugar-free, probiotic cell count, etc., etc. These are institutional intervention to ensure a market which demands a more informed product, right? So this is happening. This is happening, and then emergence of special diets like vegetarians, non-dairy alternatives, etc., etc., is is emerging. Now the next point is demographics and lifestyle. So the demographic, a report by McKinsey Global Institute says there would be 150% increase in annual consumption in emerging market. That means in real terms, from 2010, it was 12 trillion USD to 2030, it will go 30 trillion USD. Now, 650 million people exited poverty in last 25 years. More disposable income and more diversified food options as a consequence. It happens, right? Next is aging population. Now, global age expectancy, life expectancy, has increased by 5.5 years, ensuing 2000 to 2016, I guess. And this is the fastest increase since I think 1955 or 60, whatever. I forgot that exact year. So that the special needs. So that what does it imply? That means when you are getting life expectancies, people are living higher than before. Average 5.5 years. That means there is a market emerging for design of food to serve this population, right? Say for this, I will shuffle my PPT, and these are some products like age of thoughtful, right? Keto diet, lactose free. These concepts are coming up. Okay. Next is industry consolidation. Yes, in dairy, say for example, 9 years before, Lactalis Group acquired Tirumala and to enter dairy market, and subsequently they also acquired Onic Milk in MP, then Prabhat Dairy in Maharashtra. Recently, CHR Hansen has been acquired by Novozymes. Merged with Novozymes, and we are not CHR Hansen. We are now Novonesis, right? So these are the forces. Where these are implications. These have implications: product rationalization and product diversification, and the future strategic choices are happening based on this, industry consolidations. Next is private label also. Private label in India in organized retail is not that big. It's around 3.5% as of now. The positive side is that high growth mode. And this is positive sign because of entrepreneurs. Because when large retail chain exists in a country, the entrepreneurs, the incentive to piggyback into their reputation and showcase their product in their shelf, right? So that's when we see larger and larger penetration of organized retailing, and it will correlate with the larger and larger proliferation of startups in food, particularly in food and beverage, whatever it is. But these have two things have positive correlation with each other. Now, sustainability and CSR. Now, sustainability is now one equation of globalization is resource R is equal to G. Resources are global. Now raw materials, food ingredients, and moving across the border. So the composition and upgradation of the products we manufacture. There's no issues of you cannot get to make your product what you imagine to make. Okay, so and another thing is and sustainability is a very big word across the policy tables of every industry, and particularly food and agri, right? So it's going to be a major imperative for the CEO or the directors of any company to make a sustainable business case, to adopt sustainability in a more business centric way in their policy. So these are the forces which are changing, and these forces is creating a headwind. Headwind means throttling some of the legacy products, like for Coke, Pepsi's conventional products, and giving tailwind for some of the emerging products, like you are seeing in India, better alternative of probiotic juices. Then we are seeing good growth of kombucha. Though it is very small scale and very scattered across the in India, but it's growing in a high grow way. I mean, we are seeing beverages like non-alcoholic beers, alcohol-free beers. Okay, so this sort of thing implying something. Now, based on the observation, we have realized that the world is shifting in a new paradigm. Okay, now previously quality equals to price. Now consumer wants value for money. Previously it was fresh or safe. I mean, either you can have a fresh product or safe product. People, consumer mindset was fixed like that. Now the mindset is changed. Consumer now wants that I want a product would be fresh and safe, both. Now, previously hidden or canned product was more marketable. I mean, people was okay with. Now people want a product which is partially visible or full visible, transparency in packaging. Previously snacks were just tricks. Now people want snacks, even snacks in healthy. Previously processed was acceptable. Now processed food is not acceptable. I have recently read a book on ultra processed food. And if you read the book, you will understand the implication, what processed food actually means, and how it is designed, and how it is designed to make us sick. Okay. Now, we have identified these five. These are the consumer value drivers. Now, the consumer wants these value drivers. Your product should be authentic. It should be safe. It should be tasty, it should be healthy, and it should be convenient also. That means a product which will compose of this overlapping Venn diagram. And the product should also be a value for money, particularly for Indian context. Now, in the pursuit of real food is a constant negotiation between five values and solving the dilemma. Now that means your job as an entrepreneur is not about just to make a food. It's about a consumer which is confused, which consumer base which is in a dilemma. You have to solve them. I mean, they want a product which is tasty and healthy. Now, how can we do this? Say, for example, for the example of people find healthy foods unappealing and crave foods like snacks and other highly processed foods that are high on calories, poor on nutrients, and laden with additives. Now, can we make a product which is both tasty and healthy? Now, can you make a protein yogurt with rich or fresh flavor sourced from local fruits? I was talking in one of the seminar in our institute, I think, around 4 years before, where, in the northeastern part of India, there are lots of authentic fruits which you cannot get anywhere. So if a yogurt parlor can be envisaged where yogurt is made, best yogurt is made, and the fruits from local area can be sourced and used as an ingredient in the yogurts. Okay, right? So that sort of thing. that sort of thing, that sort of gross idea. I mean, you will work a bit, there's a lot of intensive work will go on, but that's a gross idea. The post product should be tasty and healthy. Next is convenient versus healthy. Convenient, we say, for example, McDonald's real value, MACD. Its real value is not its product. If you think a bit deep, its real value is convenience. That means its real value is time. Now, can we make a product which is healthy and very, very convenient? For that, I have to shuttle once again this to show you some examples. Now, see, this is the product. I mean, this is BioMilk, and they have made a solution. It's developing technology to make human milk outside body, produced from mammary cells. We are making the future feeding fearless and 100% human by offering families a new option. And so that sort of dilemma solving is going to be the key winning factor for any entrepreneurs who are going to be successful in today's time. Because a mother who goes to work thinking about his or her kid at home under the custody of a caretaker or any daycare unit is health and well-being, right? So that sort of thing, I mean, is very, very is going to be higher odds of success in today's case. Now, healthy and safety. The healthiest foods are those that are nutrients dense and contain no chemicals. But such unprocessed fresh foods tend to be unstable and present a safety risk naturally. When I go to market to buy fish, I always ask from where you have got. If they say that's from AP, Andhra Pradesh, I stay in Mumbai, and I don't buy. I want to buy the fish which is live in their drum. So that is the dilemma. So when they are saying that it's outsourced, it's sourced from far away place, I don't buy it. Now, can we do that? I mean, this type of dilemma solving is very, very important. So say, for example, another time I have to again shuttle it. So if you make a salad with a fruit salad or vegetable salad, what it is. But if you make a salad and you spray with bioprotective cultures and pack the salad in a modified atmospheric packaging condition. So these two technology, bioprotection and modified atmospheric packaging, is solving your issue. Okay. So that sort of thing is what we need. Now I will go slowly with some, with giving you some ideation in product. Let me check it is not moving. So it's all about fermentation is all about fermenting the sugar. I mean, basically. Now we have different products like sugar fermented sucrose. We have solution for juice fermentation, and we have solution for malt. Now, sucrose is, ideal for clean fermentation. We do it with mostly in the cases Lactobacillus plantarum. And if we use a yeast which is called non-Saccharomyces, that means that they don't produce alcohol and they actually ferment. They don't produce alcohol, they actually ferment and in presence of oxygen. And as a result, they produce lots of aroma compounds. So these two is one of the combo ingredients which are being used in industry
Rohit,
today.
sir.
Yeah. Am I out
sir,
of time?
Yes, sir. We are running short of time. Kindly complete your presentation in few minutes.
Okay. So that was my. Now see the examples. What you can do with fermentation technology. You can add flavor, structure, antioxidants, and color in tea. Now, for botanicals also, you can add flavor, bitterness, and anti-inflammatory functionality. For fruit juices, fresh or dried, etc., you can add flavor, vitamins, and colors. Coffee, flavor, caffeine, and bitterness. And hops is an ingredient for making beer. And we also do antimicrobial. It also increases flavor, antimicrobial properties, and bitterness of hops. Now, what is this? This is the concept what we are working on. We call it SCIB, symbiotic combination of identified bacteria and yeast. And this bacteria is mostly lactic acid bacteria. In the case of fermented beverages, we are taking Lactobacillus plantarum, and yeast is Pichia cluveri. Now, the general principle of the working of this combo, bacteria and yeast, is that this Lactobacillus bacteria, ferments the sugar, and when it's fermented, and it ferments so fast that the spoilage organisms cannot grow. That means it works as a barrier or hurdle to other microbial spoilage causing organisms. So it makes a context. It makes a context wherein this yeast, the Pichia cluveri, can work optimally because there is nobody to attack its functionality. So this is the principle we work for making non-alcoholic beverages, particularly non-alcoholic beer. I will show some example like fermented veg juices. Okay, this is the gross level. Fermentation will add acidity and crispiness and will reduce the earthy and grain of flavor. Okay, so this is very low capital intensive thing. It's not a big deal to start this product to make at the home brew unit. So you can scale it up. Then fermented tea. Fermented tea, say for example, in present in Indian context, where kombucha is being made with SCOBY. SCOBY is symbiotic culture of bacteria and yeast. Now, when you make kombucha with SCOBY, it's good to make SCOBY-based kombucha at home level. Now, when you scale it up, say for example, from 5 liters kombucha at home, you want to make a commercial enterprise which aspires to make 5,000 liters a day, then SCOBY concept is not scalable. Your product will become inconsistent. Your fermentation time is inconsistent. So these are lots of constraints will arise when you scale and you want a greater and greater market linkage. To solve that issue, you have to shift from your home-based SCOBY to applied fermentation solutions from companies like us to make your kombucha lactic acid based. Right? There are products in market in India which we already launched. Okay, they had a problem scaling up. and we solve the problem very, very easily. That's the thing we are adding. Now, when you are fermenting the tea base with lactic acid bacteria, and subsequently you add Pichia cruberi, that non-alcohol fermentation yeast, and it adds to the flavor. And you subsequently add some acetic acid to get the authentic kombucha flavor too. Your product is ready, and you do the in-bottle pasteurization. So you can send the product across India, even export. We have made product fermented tea in India, and we are giving shelf life of 9 months in ambient condition. Just imagine. And a non-alcoholic beer. Most of the non-alcoholic beer you are seeing in the market are made in a very, very makeshift way. They are importing some malt extract from Germany or Netherlands, and they are mixing this non-alcoholic beer base, diluting it, adding a flavor in it, and packing it. Okay, that is the formula of the non-alcoholic beer, which is prevalent in market or most visible brands in India. But these non-alcoholic beers are not made with the brewer's passion. You understand? This brewing profession, I am from dairy technology, but I work with lots of brewers. In dairy technology, it's all defined. But when you are in a brewing house setup, the brewers is like artist. Okay, so they can talk with the yeast, they can talk with the environment, it's a different skill. Now, there is a solution where you can use some strains of yeast which will require the art of a brewer to make an authentic product, not a ready-made concoction. Okay, and this technology is not that very capital intensive too. If you are making 5,000 liters and less, it's very, very low capital intensive. Okay, so there are lots of issues in India. A brewing unit cannot make a non-alcoholic beer without giving the same tax, excise duty as beer. There are lots of institutional voice India is having for this. But any beer company, non-beer company, any beverage maker, any startup can make it very, very easy. And you can go to market it fast. Okay. Yes. Next is coffee fermentation. Just one slide, I will complete. One thing what is happening in. Now, I did not understood what is coffee beyond a instant powder. Even 1 year before. Now, when I came to non-dairy fermentation technology to explore business, then I understood that the world of coffee, the coffee brewers, the coffee connoisseurs are very, very different. And there are lots of technologies to make coffee in home. Now, there's a concept called specialty coffee. And specialty coffee is valued. Specialty coffee is valued based on the aroma profile. And unlike ghee, where we don't do any scoring of the ghee, but coffee makers give a scoring to their specialty coffee. And based on the scoring, the prices varies. And the prices is exponential, goes in exponentially high with a linear increment of point. Say, for example, if your coffee scores 80, it goes to 85. The prices will go for 3 times that way. That's the implication. So we are seeing that lactic acid bacteria, along with flavor producing yeast, playing a significant, very significant role in this, particularly in the context of climate change, where raining pattern is changing, sunshine is changing, and all our agroclimatic ecosystem is changing as a consequence. The application of these products are showing very, very profound result. So it's about how Coca-Cola was successful previously. It was not that Coca-Cola was positioned in the market as a first beverage. No, it was positioned as a market and it is a brain tonic. And there are lots of medical and health benefits they claimed, and there was no restriction at that time. And that made for gut health, Coca-Cola used to claim that it's good for gut health, right? That time was the age of marketing. Now today's time is not age of marketing. The age of marketing is shifting. I mean, it's drifting slowly, and the product age is coming. Today, when we buy product, we see the Amazon reviews. That's creates most impact for our buying decisions, right? So the age of brand is slowly shifting, and the product age is coming, and that means that's the opportunity for entrepreneurs. Okay, so this is one of my picture where I made one of the brewers with his brewer's passion non-alcoholic beer in Pune. Thank you for listening to me.
It was a really very informative presentation. Thank you very much, sir. Now it's time for the open discussion and concluding remarks. And for that, I request all the three speakers, Dr. Surajit Mandal, sir, Dr. Kanti Kiran Kondapudi, and Mr. Sumit Saha, to switch on your video. And for this session, I invite Dr. J.B. Prajapati, sir, retired principal of our college and chairman of IDA, Indian Dairy Association, West Zone, to kindly coordinate the open discussion session. And Dr. Sujit, please share the questions of participants with JB, sir.
Sure. Sir, James, we are unable to hear you.
Am I visible now? I am not visible?
Yes, you
So
are
you are
visible.
visible.
Okay.
You're visible.
Yeah, thank you.
JB सर, प्रजापति सर, आपका माइक म्यूट है. सुमित शाह जी, आप ये स्क्रीन को बंद कर दीजिए. स्टॉप शेयरिंग.
Stop sharing my webcam. अच्छा. Okay.
Just
Please,
so that everybody can know.
Stop showing. Now stopped.
Yes, now it is stopped.
So, can I start then with the questions? JB, sir? So, the first is for Dr. Surajit Mandal, sir. I'll just read out the questions from the participant. Also, to let the participants know that I have unmuted everybody. You can ask your questions to the speakers in case you want to share your views or you want to ask directly to them. You are on unmute, so you can ask. First question is for Dr. Mandal. 1 second. So, sir, this question for Dr. Surajit, sir. It's asked by Dr. Karthik Bajpai that the selection of various starter classes to be used together is contingent upon the compatibility of the starters, which you have mentioned. So, what are the factors that are considered when using 2 or more starter classes simultaneously? Also, how can one address the various challenges that may arise when combining different starter classes? Can you hear me, sir?
Hello.
Sir, can you hear me?
Yes.
Yes, sir. There's a question from one of the participants, Karthik Bajpai. He's asking that the selection of various starter cultures to be used together is contingent upon the compatibility of these starters, which you have mentioned. So, what are the factors that are considered when using two or more starter cultures simultaneously? And also, how one can address the various challenges that may arise when combining different starter cultures?
Obviously, the compatibility of the starter culture is very important. When we are talking the pairing or mixing of the different lactic acid bacteria to get the good fermented product, then obviously the first compatibility whether the bacteria is inhibiting each and other or not. Then first is the individual culturing. Their performance, how they are behaving individually first. Then after that, combination. Then if the combination gives some better result, then obviously we can say there is a compatibility. If the combination gives the individual like result or the less result or particularly the more fermentation time as compared to individual or less flavor production as compared to individual, the less particularly quality or particularly body and structure also, okay. So then obviously the culture compatibility is not there. One is the time of fermentation and also the quality attributes. We have to check and vis-a-vis their proportion, particularly the dynamics of their growth, the number of the cell, active cell present. Obviously, the one effective method is particularly the DMC or microscopic method. Then when the two cultures are going, then after inoculation, what is their particular ratio? Then after 1 hour, 2 hour, what is the ratio? So it is there. This is the particularly the physical method. It is a real-time method. And after that, vis-a-vis, we can particularly culture them, enumerate them by culturing technique, the plating technique, dilution plating technique. And obviously the acidification kinetics study. There is the growth and acidification. Individual vis-a-vis the mixed culture population. If that particularly mixture is performing okay, so then we can say compatibility is there.
Okay, thank you. So, one more question is there for you actually. Same question to Dr. Mandal again. What measures should be taken in the event of contamination by coliforms, considering that among them there may be some strains of E. coli which under different circumstances could serve as starter cultures?
The one thing is there, the contamination of the starter culture. Obviously, if the starter culture, particularly the different tastes are there, there is a quality evaluation. Then obviously presence of the coliform, it should be tested. If there is particularly the mass contamination with the coliform, then obviously that culture should be rejected and fresh culture will be taken. Or if the culture is not fresh is there, so then again we have to go for the isolation, that particularly contaminated culture. Because the coliform presence is not desirable, because it is particularly the lactose fermenting bacteria. It is mainly the gram-negative and also the heterofermentative. Then I think if the heterofermentative is there, then obviously gas production among the any set type of product will be there. And so sometimes the presence of the coliform indicate the bad hygienic condition. So that's why we have to go for that in that direction.
Okay, sir. Thank you. I think the queries for Dr. Bajpai have been answered very well by Dr. Mandal. So, sir, one more question for Dr. Mandal again. This is from Sunil Meena. He has written that it was a wonderful presentation, Dr. Mandal, and it's very good to listen to you after a long time. I have one question, that practical problem we are facing in our lab. We have procured commercial culture, DBI provided culture actually, and we are not able to efficiently propagate the DBI culture. Please let us know, is there any particular different protocol for commercial culture?
So one thing is that propagation of any preserved culture, okay, that is either probiotic culture or other culture. So some methodology, obviously it is there, but it will vary from one organism to another organism. Particularly, some of the organisms, they need the milk medium for their growth. Particularly the laboratory medium, the MRS growth or M17 growth, so their growth is very slow and sometimes fail to grow. So that condition can be investigated, and based on that, that nutritional supplementation should be provided.
Thank you, sir. So one last question for you, again from Dr. Karthik, that can jaggery be employed in the preparation of mixed dahi, considering its potential role as a prebiotic?
Potential role?
The question, I'll repeat the question. Can jaggery be employed in the preparation of mixed dahi, considering its potential role as a prebiotic?
Potential load of prebiotic.
Yeah, potential role as a prebiotic.
Or a prebiotic in mixed dahi?
Yeah, I read the question. He has asked, like, he asked about jaggery.
Jaggery,
That
one
jaggery would be employed.
Jaggery, good. Jaggery.
Oh, good.
Good, yeah, good.
Normally, in mixed dahi, majorly the cane sugar is used. Jaggery can be used. But if that contains some of the prebiotic, so that can give some effect to consumer. So that should be ascertained. It contains the prebiotic, it contains this much amount of the prebiotic that is helpful for the consumer.
All right. Thank you. I think you have answered all the questions, sir. I think it was wonderful listening to you after a long time. Are there any participants who would like to ask directly to Dr. Mondal? You are on unmute. Any participants in the meeting you want to ask?
Excuse me. I have a question in the chat box. Can you read it out? I have a question in the chat box. Can you take it, please?
Myself, Dr. D.M. Gandhi.
Okay, in the chat box. You can read it out.
Is it audible?
You can read it out, in fact, since we can hear you.
Hello.
Yeah. Greetings from me, Dr. Suma Mugali, Principal Scientist, Plant Breeding. Am I audible, sir?
Yeah, one second.
Am I audible, sir?
Okay.
The question is for Dr. Kanti, right?
Yes,
Just
sir.
1 second then, sir. Yeah, just a second then. Okay, so, Dr. Aswari, we have one more questions for you. So, thank you, sir. So, we move on to Dr. Kanti now.
I think so I am taking permission from the chairman, so I have to go some market for my personal work. So, sir, I am leaving to Kandal market. I have to meet someone.
Okay.
Sir? Yes, sir.
Okay, no issue.
Thank you for giving me the opportunity to in this interactive session also. Thank you.
Thank you very much. Am I audible now? I have just connected from my mobile now.
Yes, sir. David, sir, you are fine. You are audible now.
Yes, sir.
Okay. So we had a very nice presentation from three eminent speakers, and definitely all the three areas have been covered, including starter cultures and industry perspective. So let us first complete the questions from the audience, if there are still more. Any questions from the audience, please?
Yes, sir. Dr. Mitchell, can you read it out from the chat box?
1 second. I'll
Sujit.
go ahead. Yes, sir. I'm on it.
Sujit is
Yes, sir. Yeah, I will do that. 1 second. Are you Dr. Mugali, right? From Dharwad?
Yeah.
It's better. Yeah, it's better you can ask the question directly to Dr. Kanti.
Yes.
Hello.
Sir, first of all, I thank you very much for your wonderful and comprehensive presentation. Actually, I'm a breeder, flaxseed breeder, and I have bred around 300 advanced breeding lines to mutation. Some of them have been created using point mutations because I've used EMS. So I expect some qualitative changes in these breeding lines. And a few of them we have characterized and have come to know that they are rich in this tyrosine and phenylalanine, which presumably are precursors for dopamine. So that can also go as a functional food. And we have biofortified them with SDGs. lignans, predominantly secoisolaricinol diglucoside. So, can we collaborate with you so that we can take them forward to be used as functional foods, sir? Kanti,
Sure,
sir?
ma'am. We can always collaborate. So we can discuss more about because I don't know what exactly you are referring to as a plant breeder at this point of time, but we can deliberate, and yes, we are open for any kind of collaborations. That's not an issue.
Yes. Yes. Can you leave your contact number or email in the chat box, sir?
Yeah, I will share. My email I will share.
Yes. Thank you so much.
I think it will be shared by these organizers.
Yeah.
So let's move on with the queries. Thank you, Dr. Goel. One more question.
Actually,
Dr. P. Yes, sir, please go ahead.
I have one question for Mr. Sumit Saha.
Yes, sir.
Actually, you made a nice presentation about these new foods and future foods and other things. I would like to especially know about the foods with incorporation of probiotics, live probiotics. What are the new things going on in that? The foods with added live probiotics.
Actually, sir, we are working at, it's not working. In some cases, it has been also commercialized. Fruit juices with probiotics. Fruit juices. Fruit juices, fruit juices, you can accommodate vegetable juices like beetroot, carrots, etc. But this is one of the space where probiotics are getting applied. People are talking about probiotic in coffee too, but that's for just for there are something which we do for the sake of doing. There is no significance in that. But I think probiotic in fruit juice and vegetable juice is going to have market.
And any work on this new designer probiotics, that means GM modified probiotic strains, Christian Hansen?
No, sir. No. Christian Hansen is avoiding. No CRISPR technology here. We are very, very, very natural.
Okay. That is good.
Well, I have one question for Dr. Kanti. Can I talk?
Yes, sir. Please.
Yes, Dr. Gandhi.
Is it audible? Yeah. Dr. Kanti, just I want to know, have you tried any ORS with the incorporation of selected probiotic culture to control gastrointestinal disorders?
No, sir. We haven't yet tried including these probiotics along with ORS, but it is a good suggestion. There are some reports people have been working on.
We also worked in NDI. Some students worked and they got very good promising result by using whey as a base. Whey, is quite rich source of ORS and all these electrolytes also, except one or two. Otherwise, it is best, sir. If you dry it and add the culture, it is highly therapeutic in nature and you can control. Even a palatable product also itself, because ORS is coming in Tetra Pak also. Is a quite palatable. People, children particularly, they enjoy this one. Even you can try this product and such thing by adding, incorporating the ORS in selected culture, probiotic culture in ORS. So just like Yakult, they are making a product is different, of course, compared to ORS, but you can try it also. Thank you.
Sure, sir. We will try that.
Sir, I have one question actually. Can you hear me, sir?
Yes.
Sir, one question I received from IIT Guwahati, Dr. Goel. How there are certain yes, congratulated you first for your presentation. It was a wonderful presentation for him and his lab. That's what he mentioned. One more thing here that there are certain challenges in bringing bacteriocins into large-scale application. Like firstly, bacteriocins obtained by traditional separation methods such as genetic engineering to construct recombinant cells have low yields and takes long time. So while chemical synthesis methods are expensive and not suitable for large-scale production. So what are your views on this issue, which is sometimes there is an instability of bacteriocins under low high pH and pepsin influence conditions. Should I repeat the question once again?
So this is to whom?
So this was you actually, sir. Kamti sir, this question was for you from IIT Guwahati.
Bacteriocins. To me?
Yes, sir. Yes, sir. The question was for you.
No, I
Should I
haven't
repeat that again?
worked on bacteriocins actually, so I don't have much knowledge about it.
Okay. So
Actually, I could not get the question, Dr. Sujit. Hello, Dr. Sujit.
Yes, sir. Yes, sir.
Can you briefly just what you or she wanted?
They want to know, sir, about the instability of bacteriocins under various low or high pH or pepsin influence conditions. So, because the degree of expression of bacteriocins under harsh GI conditions has not been elaborated quite recently. That's what they wanted to know.
Yes, I think the question is right, but bacteriocins are itself metabolites, and it is expected that they not only be getting produced in the product, but they are also expected to be produced during the gut transit and maybe also in gut. So if it is there, hardly other things matter much. So it is not to be treated as a separate ingredient, but it is something which is continuously coming out from the culture which you are consuming. So probably that will become a little bit irrelevant here. Anyway, but to continue with the question to Dr. Kanti, actually, Dr. Kanti, I'm very happy that you have done very nice work, including some prebiotics. And probably the prebiotics ingredient as it is purchasing from the market is very expensive. So we go for natural materials to be used as a prebiotics. And we select such a natural material which will also be a source of other nutrients. Now, there are two questions which come for prebiotics. Apart from helping the probiotic organisms in the gut, the prebiotics also continue to work in the colon and also affect some other bacteria and have some other effects. So, what are other things which you expect from the natural prebiotics, and are there any studies that what is happening really in the colon? Because last 2 days I was hearing Yakult, and then a lot of discussion was there that in colon also work is going on. It is not simply that it is passage from the intestine and then going out.
Yeah.
Any comments on this colon?
My observation is, they're basically they are fermented to short chain fatty acid. That is point number one, that everyone knows it. But second of things like they per se interact with the immune cells. Some of them, for example, arabinoxylan, which is a non-starch dietary polysaccharide, which mitigates the TLR4 receptor. So there are some studies on that aspect as well. So they mask the TLR4 receptor. Once it is masked, so then it regulates the immune system directly. That is one aspect of it. And then there are some like soluble and insoluble fibers, and then how do they stimulate the gut hormone secretion, enhancing the stabilities. So it's a plethora of work in prebiotics itself. So
yes,
to
it is more complicated.
Your first suggestion, like the prebiotic which is being purchased from market, yes, we agree with that. So in-house, we are also developing some kind of oligosaccharides using cost-effective methods and from the agricultural waste, especially from this potato industry. So we are working on making into non-digestible carbohydrates. That is one aspect. And the second aspect which we are working, and I have not shown here, we are using some brand components of this.
I think we lost Dr. Kanti.
Yeah. Dr. Kanti's audio is gone.
Yes, sir. Should sorry, sir.
Are you listening, Dr. Kanti?
Yeah. Am I audible?
Yeah, you're audible.
Yeah, now audible.
Yeah. So we are developing in-house our own prebiotics from the starch-based industry using cost-effective methods. And secondly, we are working with the bran portion of the cereals. So this bran portion of the cereal is rich in dietary fiber. We do modifications using chemo and enzymatic methods so that bran, which is called bioactive bran, can be used as a dietary fiber as well as encapsulating matrix for the probiotics, which prevents the loss of probiotics during gastrointestinal transit. So such kind of symbiotics we are developing on. So now initial studies we have done. So more focused studies we are carrying out in our laboratory. But yeah, point is when buying and using it as a prebiotics is commercially not viable. So we have to have our own strategy for it.
Okay, that's thank you.
Sir, I
Dr.
have a
Sujit?
question. Dr.
Yes, sir.
Sumit.
Yeah,
Yes.
Yes.
So you said that you are developing some kind of probiotic laden fruit juices, right? So we heard that.
We are not making probiotic laden fruit juices per se, but we make a product which the manufacturers use. Our job is to make a product which would be stable in fruit juice matrix, and it's there.
So you mean to say that you are developing probiotics that can suit?
We have already developed which can be applied in fruit juices, and your storage condition should be in chilled condition. It's not be ambient condition.
So how do you take care of these effects of pH in the fruit juice on the stability of the probiotic strains?
Oh, that is by there is strict temperature control. One of this, right? And you have to put one variable. I mean, as a retailer, you have to retain its temperature perfectly.
No, I am asking about the pH, acidity. So how do you regulate? How do you? Some of the juices are acidic. So how do you?
So it comes to intensive R&D. R&D, scientist's job to find the strains. All the strains are not fit for high acidic condition.
Yeah.
Say, for example, in a more general way, probiotics. What do you call probiotic? Even for human consumption, any probiotic which we consume, it should be powerful enough to withstand the bile and bile conditions, acidic conditions of our GI tract. That is why we add extra strains to call a curd probiotic curd. That means there are strains which can be live throughout your GI tract, from top to bottom. I mean, from mouth to your end of your intestine. All the strains cannot. So those strains which can withstand are probiotic.
Yeah, that is true, but it is the transit time, I think, Mr. Shah, because how much is the time exposed there? Because transit time in the stomach is very short, but when you are putting in a product, it is long storage. Even if you gain 1 week storage, it is something which probably it may be microencapsulation or something else or some other treatment or maybe some facial buffer, which may be a trade secret for Krishnan Hansen. I think we should not ask this question because
I can ask, but he cannot.
He will not.
No, whatever. This question is very important question actually. It's very important question. I will talk to the relevant scientist and I will get back. Yeah, I will get back to Subroto Hathi or Prajapati sir. He will connect. He give me 7 days.
Yeah.
Okay. Thank you so much.
One more question for Mr. Saha. It's from Karthik. Again. He's asking, sir, what is the probability of achieving success in exploration of the untapped market for traditional Indian fermented dairy products and other indigenous beverages within the Indian market, and subsequently expanding the market presence of these products on a global scale?
Traditional Indian dairy products. That means dahi lassi.
Yes.
So when when the industry is expanding, it's around dairy industry is growing in double digit, right? And fermented is going around 20% plus. The incentive is the infrastructure is getting transformed in a very, very fast. When your roads, when your bridges, you get highways, right? That means speed. And speed means you don't need any dryer anymore, right? So any small entrepreneurs can handle 1 lakh liter milk and make milk, dahi, curd, etc., and distribute far away in rural households also, right? Because of the infrastructure is improving, the success of dairy, given dairy is still 35% formalized, so there is lots of scope for everyone to have a bit of the pie, I think.
Thank you.
You understand my point? Yes.
Yes, I think it has been well answered, well taken, and I think the queries for Dr. Karthi has been answered by Mr. Sumit. So one more question for you. Could you please outline the procedures utilized to extend the shelf life of non-alcoholic beer to a duration up to 9 months?
That it is non-alcoholic beer. If you see, this is, you make the beer and you have to do tunnel pasteurization. You have to do tunnel pasteurization. And the 9 month shelf life is not about non-alcoholic beer. It was a kombucha brand.
In continuation with this question, I have one more similar question from Dhanjat Bhagi friends. Like they're asking some, can you give some insight from the solid state fermentation best products?
What?
Can you give some insights on the solid state fermentation best products, sir?
Solid state, we are not yet. But again, we are doing fermentation in coffee, and coffee, the fermentation profiles are very, very different. We do coffee cherry fermentation, whole cherry, we call naturals. There are some process where we demucilage it and we add the culture. We call it honey process. And there are some process where we demucilage it, wash the total mucilage and wash it, then we call it wash process. So there are three, technology. There are lots of derivative technologies of these three core technologies also. But these are mostly three technologies where we use. But coffee, solid state fermentation as such, by definition, we are not into it. I don't handle it.
Fine. So from Dhanjat Bhagi friends, is there anybody in the participant? You have a lot of questions. If you want, you can unmute and ask to our panelists. Anybody from Dhanjat Bhagi friends? Okay. If not, any questions asked, then I will ask to Mr. Saha again. One more question is, yes, so 1 second. One second. Do you need clinical trials, or what are the regulations based on a probiotic or symbiotic drinks needed before launching for general public?
We need, what is the question, please, again?
Clinical trials, or what are the regulations on probiotic or symbiotic drinks needed before launching for general public? Regulations.
See, I have seen people launching kombucha with probiotic claim, okay, and probiotic claim without certifying the product for the CFU level at the end of shelf life, etc., etc. At this point in time, I think kombucha is like orphan. It's at no mother father. No FSSAI has defined the definition of kombucha, right? So even some kombucha which are made in an authentic way, I mean in SCOBY, with SCOBY, if you go randomly take a sample of SCOBY based kombucha and check the alcohol, it may be higher than 2%, maybe higher than 2% alcohol. Okay, so this segment is yet to be addressed by FSSI, number one. Number two, regarding probiotic kombucha, if you make in an authentic way and if you consume it in a the way the product has to be consumed, it has beneficial products. I mean, it's good for the gut. But how much CFU in a technically more technically right way, as we in a regulatory perspective, it has not been touched by FSSI yet. So there are lots of brands which are saying that it's probiotic, and it's probiotic, but it's not tested. If made in authentic way, yeah.
So one last
Just
question
to add to that, Dr. Sujit, actually, as far as the regulatory side is concerned in India, FSSAI has only made one clause that if you call any product as probiotic, you should have 10 to 8 cells per serving size. Now, maybe a kombucha or anything, or the product may not be defined, but if you use the word probiotic, it is mandatory for you to follow that requirement. So if such things are there, if your calling that as probiotic is not following, there can be some legal complications that somebody can sue it, because they have got license as a proprietary food. It is a proper. All these things are proprietary food which are not defined. But apart from proprietary food, their name, they also claim that it is probiotic. They have to meet those requirements of test 8. So because nobody is doing anything in this, but if somebody choose, there can be repercussions of that. Same thing happened with soya milk, because you cannot call any other drink as milk, and somebody was calling soya milk, and that is why I think Amul filed a case, and now everybody has stopped labeling this as soya beverage now or soya drink. So there are regulations. There is nothing on health aspects. Only count matters. That's all. That is the only thing which is present. But probably in future, we'll also have that what to do for health claims or something like that. Because health claims are totally unregulated now. It will become only if that product goes under the FDA or the drug also.
Yes.
So now the field is grey. Okay, I think it is almost 1:20, Dr. Mittal.
Thank you. Yeah, sir, I think it has already answered. So I think we'll take one more last question. Again for Mr. Saha. So this is the last question, sir. This is from Shapan Rahman. He's texting you on behalf of Holistic Health Unity Private Limited. So he's writing that we are planning to introduce a probiotic beverage in the market. So the question is, can we buy strains on the market that are available, or we have to go through some other?
You can contact me. Simply put, you can contact me. I can give you samples. You can take trial. I can give you guidance. Do that.
I think this has been well answered. If you need the mail ID, you can write to us also.
So, still as a follow-up of this question, I wanted to ask, so if they take some strains from the market and use it for their own drink, is that acceptable, or are there any regulations to be followed in that?
You are using the product available in market, and you are using the strain.
No. So this company,
that is
so
what
they're planning to introduce a probiotic beverage in the market, and they want to buy strains from the market that are available. I mean, would that be allowed if they just like buy certain strains and use it for the development of a probiotic product? Are there any regulations to be followed for that?
For buying?
Yeah, actually, this company, the question which this company was asking is, they are planning to introduce a probiotic beverage in the market. So, is it okay if they buy the strains from the market that are available, or do they have to go through some other protocol? So, like, my question and the follow-on to this is it acceptable, or are there certain regulatory requirements or certain licensing?
I think it is acceptable. I think it is acceptable to buy.
Okay, sir. I think we are done then with the questions. Over to you, sir. Jameson.
Yes, I think there is some. Am I audible now? There is something
yes, perfectly,
problematic. Yeah. So I think we had a very, very interesting discussion, and probably tomorrow also we'll continue on some other questions. I'm thankful to organizers for giving me chance to chair the session, and thankful to all the speakers for being with us. So thank you very much. I think you can have a concluding formality, Dr. Mittal.
Yes. Thank you so much, J.V. Prajapati sir, for moderating the session. Thank you all the three speakers for answering all the questions patiently. And thank you, Dr. Sujit, for sharing the questions on behalf of participants. So here we come to the end of first day of today's webinar. Thank you everyone for joining us today. On behalf of organizing team, my heartfelt thanks also goes to all the three eminent speakers for sharing their expertise and knowledge with us. Thank you, J.V. Prajapati sir, for accepting our invitation, for being the coordinator of open discussion session. We will start tomorrow's session at 10 a.m. sharp. So I request all the participants to join us tomorrow in the morning. Thank you, everyone. Have a great day.
Thank you.
Thank you.
Bye.
Thank you. See you tomorrow.
Thank you.
sir.